Hi, and welcome back. I'll take you through this lesson on Data Analytics Overview. In this lesson, you'll learn the steps in the analytic process, the skills and tools required, the challenges that you'll face in the data analytics process, the exploratory data analysis or EDA technique, data visualization techniques, and the use of hypothesis testing to analyze data. Today, we have access to a lot of data, but unless we know what to do with it, it won't be of any help to us. Let's take an example of a fictional bank statement to understand this. A bank statement usually lists every single transaction, either a deposit or a withdrawal, along with the balance amount left in the account, as shown here. Though the statement is highly descriptive and is a good source of information, it doesn't show you the spending or saving patterns of the user. But the moment you present the same data as a line chart, you can easily spot the overall transaction pattern. If you compare this pattern over a period of 3 months, you can also spot if there is a shift from the regular pattern. Here, you can see that there is an unusual spike in the spending pattern of the user between the 24th and 26th of April. This kind of data analysis is what alerts banks to instances of identity theft or fraud. For e-commerce websites, analyzing buying patterns of users can help them understand what kind of customers are more likely to buy a certain type of product. This is how data analysis makes your data work for you. A bank statement is an example of a highly structured data set. Most data sets that you would have to work with will not be so structured. You will have to clean it up before you could use it in any constructive way. That's why data analytics involves a combination of processes to help you extract information from these data sets. Along with domain knowledge, you'll need programming, mathematical, and statistical skills to arrive at a decision-making process with the help of data. Data analytics is a step-by-step process to reach a conclusion. Let's look at these steps briefly. The first step in the process is to ask questions to identify the business problem. The next step is data acquisition, or collecting data sets related to the business problem or question from the real world. The third step comprises data wrangling, with data tools and modern technologies that include data cleansing and data manipulation. The next step is exploratory data analysis, or EDA, with mathematical or graphical output to aid data analysis. Data exploration is the next step that discovers data and identifies patterns in data. The next step is to draw conclusions and make predictions by creating training models for machine learning. This step uses a lot of mathematical or statistical functions. The last step is communication or data visualization to present the analysis work. Let's now look at each step in detail. The process of analytics mostly begins with questions or business problems of stakeholders. Here are a few examples of questions. Who are my customers? Why are my sales going down? How do I manage my inventory? Why is my system not scaling up with increasing traffic volume? Such business problems usually trigger the need to analyze data and answer the questions raised. This leads us to the next step. To answer the question or to address the business problem raised in step 1, the next step is for you to gather or collect data. This process is known as data acquisition. The main task is to collect relevant data associated with the problem. The data could be residing elsewhere. A data scientist has to use database skills to fetch the data from databases. Expertise with file handling and ability to deal with different file formats is an important skill to download and analyze the data. Web scraping is a popular way to extract information from the web. A lot of information sites provide streaming APIs, such as Twitter, Facebook, LinkedIn, and other major social media and information companies. The server logs can also be extracted from enterprise system servers to analyze the application performance and optimize the overall process. Data wrangling and exploration is one of the most important phases of the data analytics process. This phase includes data cleansing, data manipulation, data discovery, and data pattern identification. Usually, data is neither in the expected format nor is it consistent. The data cleansing process gets rid of unwanted elements present in the data. Data manipulation techniques, such as transform, merge, aggregate, group by, and reshape, transform the data and make it available for exploratory data analysis. Data exploration uses all the available data and presents it in either a numerical or graphical format. This helps to identify the right patterns in the data. The data and the underlying pattern are fed into appropriate machine learning models, leading directly to the prediction and conclusion phase. Data wrangling by far is the most challenging phase and consumes 70% of the data scientist's time. Let's look at some of the reasons that cause these challenges. Unexpected data format. A format that is new and inconsistent data creates more preparation work. Erroneous data. Data contains lots of errors and unwanted values that have to be cleansed. Manipulate and prepare data. Manipulate voluminous data using data wrangling techniques and tools and make it ready for analysis. Understand structure of data. Understand how the data is organized in the first place, linear or cluster. Plot them if possible. Determine relationship of variables. Observation, feature, and response are keys, and relationship between them must be determined. It's difficult to determine this relationship. Choose appropriate models. Model selection is based on the overall data analysis process to draw conclusions and make accurate predictions. Selection should be accurate, or it will lead to a lot of iterations and a waste of time. Identifying the right patterns and applying the right algorithm is critical. The hypothesis building and hypothesis testing process together lead to appropriate model selection. Mathematical and statistical functions have to be carefully built for the model chosen.